Hi my beautiful friends on the YouTube. So today in this video we are going to cover the contains duplicate problem. So in this problem we'll be receiving an array of integers. Suppose we are getting 1, 2, 3 and 4. Okay, and we have to check if there is any duplicate present in here or not. Okay, so now you can see that 1, 2, 3, 4 all are the distinct integers that we are receiving in our array. So that's why there is no duplicate present. So that is why the output for this solution will be false, right? Suppose we are receiving another array. Okay, this is a different example, 1, 2, 3 and 1. Okay, now you can see that obviously there is one present, one is repeating 2 times in our array. So that's why yes, in here our array contains duplicate. So this is a very simple and basic level question. Let's check out how we can solve this question using the different approaches, and we'll go from brute force to the optimal one, right? So in the approach 1, what I can see is, suppose this is our array 1, 2, 3, 1. Okay, and how we can come up with the solution, right? So we can obviously see that the 1 is repeating 2 times, so that's why this array contains duplicate. So our final output will be true, correct? So what I can do is, this is the very simple solution that I can think right now. And suppose I run a loop. Okay, this loop will go and traverse all the elements present in our array. It will go from 1 to 2 to 3 to 1, right? Okay, now I can have another loop. So basically we are using a nested loop, right? This nested loop will also traverse all the elements present in the array. Now using this first loop, we'll be getting a value, right? And using this second loop, which is a nested loop, we'll be also getting a value. What if we check them if they are equal or not, right? So if they are equal, the value from the first loop and the value from the second loop, if they are equal, then yes, the array contains duplicate. So that's why our output will be true, because the array is containing duplicate, right? And what if the value are distinct? What if the value is not equal, right? So in this case, we'll be returning false. Okay, so again, in the brute force, what we are doing is we are running a loop. Okay, using the loop, we are getting a value, and we are running a second loop. So this second loop will start from the one step ahead than the first loop. Okay, so they will be not at the same position at a time, right? So the indices will be different for both of them. Okay, we'll go into that detail. Okay, so let's check out the code. So the code for this approach will be like this. Let's create a function. Function name is contain duplicate, and we can call it brute force. Brute force. We will be getting an array, and this is how this loop will be working. We'll start from 0. It will traverse all the elements present in the array. Okay, and then we'll have our second loop, j equal to I plus 1, because the indices will be different. They will be not at the same position. J should be less than array dot length and j plus plus, right? Now here we check if value is duplicate. If value is duplicate, okay, here we'll add a condition. We'll say if array at I, if the value from the first loop and value from the second loop is same, then return true, right? This inner loop will end here, this outer loop will end here. Okay, and at last we'll be returning false. So return false, because what if the array does not contain any duplicate value? right? So this is how the code will look, and this is our brute force approach, right? So in this code, what we are doing, we are running a loop, we are getting a value, we are running another loop, a nested loop, we are getting a value. Okay, the indices are different. If okay, then we are adding a condition while checking. So if the value from the first loop and the value from the second loop are same, then return the true, right? Because the array contains duplicate. And at last return false in case. Okay, so the time complexity of our algorithm is order of n square. Okay, and the space complexity is order of 1. Okay, now the space complexity is good, fine, but this time complexity could be better, because this is bad. Okay, order of n square, we need to get it in order of n, right? That would be an optimal one. Okay, so that's why we'll go to the approach 2. Again, take our array 1, 2, 3 and 1. Okay, now what is the approach 2? Okay, so what we can do is, what if we sort this array? Okay, what if we can able to sort this array? So after sorting this array, we'll be getting the result like this: 1, 1, 2, 3, correct? So the sorting means put our array in the increasing order, correct? So after sorting, this will be our result, right? Now can we say that the after sorting, the duplicate values will be adjacent to each other, right? They will be neighbor to each other. So you can say that after sorting, 1 and 1 are adjacent to each other. Then we can check if adjacent value is same or not. Okay, so this is our second approach. So the first step is sort the array. After sorting, check the adjacent value if that is equal to, if they are same, and if they are same, then return true, because the array contains duplicate. Okay, so the code for this solution will be like this. Okay, contain duplicate sorting. Okay, so the first step is sort the input array. Sort the input array. Okay, so this is the method for sorting. Array.sort. So this is the inbuilt method in the JavaScript for the sorting. Okay, so after adding this line, our array will be sorted. Now, okay, so this is sorted. Now what is our next step? We'll run a loop. Okay, for let I equal to 0, I should be less than array dot length -1 and I plus plus. Okay, then here we will check duplicate. Let me call it a neighbor, duplicate neighbor. So if array 8i equal to array 8i plus 1. Okay, so if this condition satisfies, then we are done. We have found the duplicate. So in that case, we will be returning true. Okay, and in case there is no duplicate present, then return false. Okay, so this is how our second approach is. Okay, by using the sorting. Correct. What we are doing again, we are sorting the array. After sorting, we are getting the duplicate value adjacent to each other, and then we are just checking if they are same. If they are same, then yes, there is a 100% confirmation that there is a duplicate present. Now the time complexity of our algorithm is, because since we are sorting, the time complexity will be order of n log n. Okay, and the space complexity will be order of 1. Now this time complexity is better than the first approach that we use. In the first approach we had a order of n square time complexity because we were using 2 loops, but here since we are using sorting, so that's why the time complexity here n log n is better than the n square. Okay, cool. So now can we do it better than order of log n? Because our ultimate goal is to find out the solution which should be in order of n. Okay, so this will be our optimal solution. So how can we reach to this optimal solution? So now our optimal solution will be in approach 3. Okay, let's get back to our array 1, 2, 3 and 1. Okay, so in this approach 3, what we'll do, we need to keep track of the element we have visited so far. Okay, so our simple logic is to have a loop. Okay, have a loop, and suppose our loop is at the 0th index, and right now we have the value 1. Okay, so we can check if we have visited this value or not. Okay, then our loop will go to 2, we'll check if we have visited 2 or not. Then we'll get to the 3, we'll check if we have seen 3 in the history in the past. Okay, then we'll check 1, then we'll check if we have seen this one before. Okay, you can see that we have seen this one before, so that's why the output will be here true. Yes, it contains duplicate. Now the big question is how we are going to check the element that we have visited, right? So guys, in the previous video where I covered the some interview question, so in the optimal solution using the hash table, there I used the map, right? So map is a key value pair we can store in that, and we can track down the element, or we can check if we have seen that element or not. So that is the purpose for the map. But since we can also use the map, by the way, in this question, but since we only want to check a single value, we need to check only single value that we have visited or not. So that's why we will use a similar kind of data structure like the map, which is set. Okay, so in this set we can put our value, and we can check if we have seen that or not, right? So this is also similar to the map, but we can only store the single value in this one, right? So our loop will run, it will track 1, we'll check if 1 is okay, so this is our array 1, 2, 3 and 1. Okay, our loop will run, we'll check if our current element, which is 1, it is present in our set or not. Okay, we are checking in the past. Okay, so we can see that our set is empty and we don't have any element as 1. So that's why we are going to put this element 1 in our set, right? Then we'll move ahead. Our current element is now. So our current element now is 2. We'll check if there is 2 present in our set. Okay, so now we can see that there is no 2. Let's put that into it. Then 3, we are going to check if 3 is present or not. No, let's put that 3. Then we'll check if this one is present in our set. Yes, we have seen this one before as well. So that's why, yes, we can say that this array contains duplicate, so the output will be true. Correct? So let's check out the code. So the code will be function contain duplicate optimal. Okay, then the first thing we are going to do is create a set. I will name this set as scene. Okay, and then we are going to run a loop. Okay, and then we are going to check if scene.has, if our scene contain our current element, then in that case we are going to return true because we found a duplicate. And if our set does not contain any duplicate, then we are going to add scene.add our current element. Okay, so at last we'll return false. Okay, in case if our array does not have any duplicate. Okay, so this is how our solution is, our optimal solution, and the time complexity of this solution is of course order of n. We have achieved our optimal solution, and the space complexity will be order of n as well, because since we are using set, the number of input grow, the number of set, the values in the set will also grow, right? That is not constant. So that's why this is our optimal solution. And before wrapping up, we can also write down the solution like this, right? So since there is a benefit using the set, and that is it contain unique values. So this is our array, right? And if we put all this array in the set, so our set will look like this. It will ignore all the duplicate values, right? It will contain only unique value. This is the benefit using set, or what we can say an advantage. Okay, so in our solution we can also write down our solution like this. Okay, so the time complexity and space complexity will be same, but it will be easier when writing the code, right? So suppose we have a function and again contain duplicate, I can say simple, this is array. Okay, and what if we return, we are just returning directly, we have new set, in the set we add our array, right? We are putting our input array in the set, so result will look like this. It will give us the unique values, and we can check the size of our set, right? So after adding this input array in the set, the size of our set is 3, right? And our original array size was 4, right? So they are different. If they are different, then yes, we had definitely a duplicate, right? We'll have, okay, so in the code we'll have size, we'll check if that is not equal to array.length. Okay, then it will give us the output. Okay, it will return whatever will be here. So what we did, we put the array in the set, it will have unique elements present, and we are checking that set size. In this case, for our example, for the sake of our example, our unique our set's size is 3, and our original array's size was 4. So 3 is not equal to 4, right? So that's why it will give us the expected result. Okay, thank you guys.